I'm making this video on a beautiful, sunny, spring Seattle day because I really want to make sure that you get the information that I would give you if we were actually in class. So you should know what an antiderivative is, in that it is, if you want an antiderivative of a function f, it's just we usually call it capital F, where the derivative of capital F is the original f function. So that should be something that you learned in your previous calculus class. And I want us to be able to figure out how to find them without memorizing anything new, at least the easy ones, or the non-complex ones, I should say. So first of all, I really don't want you to memorize the formulas. There are formulas for finding antiderivatives, but you don't need to, and that just takes a lot of memorization time. So this video is about how to guess and check. Now, finding an antiderivative, we're looking for an antiderivative of this 8x plus 7, right? Because the derivative of what is 8x plus 7? That's the whole idea. So it's pretty easy to figure out what do you take the derivative of to get 8x, 4x squared, right? You just think about it again. You have to be good with your derivatives to be able to do this. And of course, to get the plus 7, you would need a 7x. Or you could add an 11, right? That would also give you the same derivative. If you want to get fancy, you could subtract 31.9. It doesn't really matter, but in fact, you could go ahead and add or subtract any constant you want, and it's got the same derivative. But what we're going to really care about is trying to find the simplest one. And in this situation, it's just 4x squared plus 7x. All right, let's think about this one, right? The derivative of what is 3 cosine of 5 theta? We're looking for the antiderivative of 3 cosine of 5 theta. So you might imagine that it's going to be 3 sine of 5 theta. That is a great guess, and I really suggest that you guess, even if it's wrong. If you guess and check, you'll be able to usually pick a better guess. So if I take that derivative, oh darn, right? Because of the chain rule, because I have to take the derivative of the inside, I'm going to actually end up with a 15 instead of a 3. So I'm bummed about that. At the same time, it's not that bad of a problem because notice I got my cosine of 5 theta. That's what I was going for. So I just have to fix it. And we do that by putting an appropriate constant in front. So instead of 3, we want 3/5. Because that 5 in the denominator will cancel this unwanted 5. And the simplest antiderivative is the 3/5 sine of 5 theta. Okay, let's do a tricky one. What's the derivative of this? The derivative of what gives you 3 over x plus 2? Well, if you know your logarithms, you can guess it's going to be that. The only problem, and this is a technicality, it's kind of tricky, is that on the left-hand side, you can't have a negative inside the logarithm. On the right-hand side, you actually can have a negative in the denominator. So what we do is we think through, well, what if that x plus 2 is actually negative? What if the inside is negative or the denominator is negative? Then we can think of it like this. That's actually true because now if that x plus 2 is negative, that whole thing is positive and you're okay. There's no domain issues. And note that if you take the derivative of that, you're actually going to get the function you're looking for. So that works if the x plus 2 is negative. And the way to put both of those together is to make it an absolute value. So that's a tricky thing. That's why you'll see in the formula sheets when you look at them, which you don't do too much, I'm hoping, because we're not memorizing. But that's where the absolute value is coming from. And so the simplest antiderivative of this 3 over x plus 2 is 3 natural log of absolute value of x plus 2. Let's do one more. What's the derivative? The derivative of what is this 2 over 1 plus 16x squared? You really do need to know your derivatives well to be able to guess and check this one. But if you do, you look at that and you're like, you know what, that's an arctangent, most likely. So do a guess. Maybe it's just the derivative of arctangent of 4x. And the only problem here is this 4, and you wanted it to be 2. So again, we fix it with a constant. Instead of having a 4, we want a 2, so of course we divide by 1/2. And that would be our simplest antiderivative. So here's what I want you to do. I know this is not class, but I want you to practice a few. Pause this video real quick. Just guess and check. It's okay if you get them wrong, get something wrong, check, guess again and check it again. Find an antiderivative for all of these things. So 1, 2, 3, pause. And now we're back. And just quickly, here are the answers. The antiderivatives for number 1. Right? Why is that the formula? Because it's work. Why is that the antiderivative? Because it works. Here, if you know the derivative of tangent is secant squared, you should be able to guess that. That's knowing how to deal with derivatives of square roots. And of course, and there's your check. And of course, we did something like this similarly in the previous question. And that's about it.